So I got my Packard Bell Platinum 2220 open here, and I'm going to be installing a 3.5-inch hard drive in it after taking the original compact flash card out of it that was serving as its hard disk. And at the same time, we're going to learn a little bit about logic block addressing. So let's get to it. So the hard drive I'm going to be installing in that system is one of these Western Digital 160 gigabyte Caviar drives. And now you might be thinking, whoa, this is a Windows 95 system being Packard Bell, and that's a pretty big sized hard drive for something like that. Well, I've got a whole bunch of these 160 gigabyte hard drives that I got in a lot years ago, and I'm finding uses for them, so I'm going to put it in this computer, since I've also recently, in a previous video, updated the BIOS on this, reflashing it to a Mr. BIOS that replaced the original Amy BIOS that was on there. And one of the things that came part of that, which we're going to discuss as well, is logical block addressing. And one of those things about these computers of this period is that many know that there was a BIOS limitation of usually around 8 gigabytes or so. Now, this was a BIOS size limitation of the hard drive. This was actually not an interface limitation. The interface limitation on this is 137 gigabytes, or basically about 127, 128 gigabytes of usable disk space. That's the interface limitation. But we can access that much available disk space with the use of logical block addressing, which is LBA28 in this case. Now, this hard drive being 160 gigabytes is an ATA6 interface drive, so this is expecting 48-bit LBA, or logical block addressing, to be able to address the whole 160 gigabytes this drive can offer. But in the case of this system, we only have 28-bit logical block addressing, so we'll only be able to address about 127 to 128 gigabytes of usable capacity on this drive. The rest of it will just not be utilized on it. But we'll have lots of disk space available on this Packard Bell. Now, this Packard Bell uses a designer tower, so the hard drive kind of sits side-saddled in it like this. So we need to put it in this holder and then slide it in there and then secure it. So I'm going to fasten this hard drive in here, and now it needs to face down like this in it. So, side. And I got plenty of 632 screws here, so this hard drive will most definitely not be going anywhere. And something else too about this hard drive is I've already gone ahead and cloned the partitions from the original 4 gigabyte compact flash card that's in here. So yes, it's a significant difference going from 4 gigabytes to 127 gigabytes or so that we're going to have with this drive in here. And this screws, there you go. However, we will have to use some partitioning software to both resize the partitions, but also to convert the Windows partition to FAT32, since the original, because of the card size before, was formatted as FAT16. So we'll have to do some repartitioning to this drive as well, which we'll look at once we get the drive installed. Basically, this should be able to boot right into the original Windows 95 OSR2 installation as is, but we, of course, until we modify the partitions, we won't be able to utilize all the disk space. So let me come over here. Platinum. So it's nice and secure. Let's get this over here. And it just slides over like that. And holds in. Take our screw and we go. Add that in there. Yeah, that's nice and solid. So we work on our power connection. Bring this down around. Power there. And then our parallel ATA cable. It is a little long. I might have something shorter in storage, but for now I will just make do with it as it is. Alright, that's the cables in. Just kind of squash it all over there. We'll just leave the inside open for now, and then we will now power up the system. So I got screen capture going. I've also got the camera at the monitor here with manual focus, so hopefully it won't keep going in and out of focus on here for the parts that we won't be able to see with a screen capture. So let's power on our system and take a look at the BIOS first. So there's our Mr. BIOS. There's a escape. We can see that it has an ATA disk configuration change, which is what we'd expect. Pressing the key to continue. So that brings us into our menu here. And we can see from IDE 0, which is our hard drive, it has 137.44 gigabytes of addressable capacity. Remember, this is not the capacity of the drive. This is the capacity of the drive that we can address with 28-bit logical block addressing. So I can go over there and we can see the capacity. It says it's ATA 4. Again, the drive is ATA 6 technically, but this only goes up to ATA 4. And of course, there's our model, Western Digital Caviar 160, so 160 gigabyte. So all should be good there. So if I press F10 and save this, we should boot into Windows 95 here with the cloned drive, which it does, says starting Windows 95. But as I say, it's got the original partition types, which is FAT16, and also the original partition sizes, which were only 2 gigabytes. So I'm going to use Partition Commander, which is a graphical user interface based partitioning software for DOS, and we will go ahead and resize those partitions for the drive. I'm noticing my screen capture over there is not picking up anything. Of course, I guess the reason it wasn't picking anything up is because I did not have the VGA capture enabled to show over there. Okay. So now we're booted in Windows. Now I don't have a mouse hooked up. I've just got the keyboard here on the desktop. But you see we booted into Windows just fine. And depending on the camera and how much noise there is, you may just be able to pick up the hard disk operational noises. It's not as quiet as some of the newer 160 gig ones I have in my drive lot, but it's also still quieter than older hard drives that I have. So we can see our windows there. But you see, these are the original partitions. So only about 2 gigabytes, and I was already running out of quite a bit of space. And then that's basically the backup partition. So what I'm going to do now is we're going to reboot into DOS, and then take my Partition Commander disk, which I should have over here. So we got Partition Commander on a floppy, and we're going to load it up. And And we'll get our screen capture back here momentarily. So Partition Commander's GUI is loading up. Now, of course, every time I do a clone, though, with one of my external computers, it pops up with this because the extended partition, which is what that data partition was there, it never comes out right when I do a clone, even though it's accessible. Partition Commander simply doesn't like to work with it, so we're going to have to remove that, but I don't care. The primary partition we want, where Windows is not affected. So go to Manual Partitioning. And look at all that free space. So our Windows installation is down at the bottom here. Let me go to that. So there's our Windows installation, and there's the extended partition, which of course Partition Commander does not like. So I'm going to first delete that partition. Okay. And then what we need to do is we need to resize and convert our Windows partition to FAT32, and I'm going to resize it to 60 gigabytes. So what I plan to do here is create two 60 gigabyte partitions. One is the Windows partition, another will be a data partition, and then that will leave about 7 to 8 gigabytes left available on the drive to use, and that will be another partition, and that will be basically for backups. So go ahead and do resize. Now, 60 gigabytes is 61,440 megabytes, because it's a megabyte is 1,024 kilobytes. So we multiply that by 60 to get 61,440. I notice Partition Commander here is a little iffy on trying to work with larger partition sizes, so I'm going to let it do that. And yes, we have to change it to FAT32, so let's enable that. Okay, I guess 61,000 is as far as we're going to get. I really wanted to try to get that exactly, but it's not going to play ball with me. So let's go ahead and create another primary. 61,000. Call this one data. Line to start. Proceed. Okay, and there's our data partition. So that just leaves something close to 8.5 to 9 gigabytes left for a backup partition. So I guess I will go ahead and create that as well. And we are complete. So we have our 3 FAT32 primary partitions here. So we have our Windows partition, our data, which is going to be like for CD-ROM images and other program stuff, and then the backup is just going to hold basically Windows and Packard backup stuff on the little partition there. So we'll have lots of disk space on this Packard Bell. Let's restart. Starting Windows 95. And now we go on our desktop, and now when we look at our partitions, we have our 3 partitions there. So now when I look at the Windows partition, it's now 59.5 gigabytes, so not quite 60, but we dealt with it. Now we got over 57 gigabytes of free space for the Windows partition. Put that one here. To the data partition. Hard drive taking a little synchronization time. So we got plenty there in the data section, and then our backup partition is just shy of 9 gigabytes. So we now have lots of storage here on this old Windows 95 machine from Packard Bell. And again, that also demonstrates 28-bit logical block addressing. The drive is 160 gigabytes that we installed, but because of the limitations of 28-bit logical block addressing for this ATA interface on this machine, we can only address up to 127, 128 gigabytes of hard drive capacity, so that later 21 gigabytes of the drive we can't do anything with. But as I say, I had a whole bunch of these, and now I've got lots of space on the machine, and because of the Mr. BIOS flash that I did on this for the previous video over the original Amy BIOS that was on there, we now get that logical block addressing on there and don't have that 8 gigabyte BIOS limitation anymore, plus we get a couple more features. So that pretty much concludes this video. Hey guys, Brian here. Do me a favor and click that like button down below, and while you're at it, go ahead and click the subscribe button and hit that notification bell so you don't miss out on any new content when I post it. See you guys in the next one.